Thank you. So our next speaker is Charles Eckel. He's the chairman of the IMTC SIP Parity Activity Group and works for Cisco. He chairs that group since several years, enabling the transition from H323 to SIP-based video conferencing system and improving SIP video interoperability in general. Charles was involved in the early days of voice of IP, including MGCP gateways and SIP proxies, as well as translators from MGCP and H323 to SIP. Charles was one of the pioneers of the use of IP telephony for radio-based public safety networks, including authoring and implementing the bridging system interface adopted by the US Department of Homeland Security, enabling voice communication among disparate radio frequencies, systems, and technology. And today, he's going to give us a review of the SIP Parity Activity Group. Charles, please. Thank you.
All right, well, thank you, Patrick. And thank you for that introduction. And as Patrick mentioned, the SIP Parity Group, it's been around for a number of years now, maybe not quite 5 years, but something on that order. So I'm going to tell you a bit about what we do, but also give you a bit of a review of what we've done, so you have appreciation for that work. And I think it's pretty illustrative of the type of beneficial work that this organization does in general. So if you look at the IMTC, this has probably already been mentioned, but just to reiterate, really the mission of it's to promote the development and use of interoperable real-time communications based on open standards. And now there's challenges with that. And you think, hey, we have these standards, just go out and implement them, right? Just use those standards, it's all great. But the problem is people interpret those standards differently. And now you have implementations from different companies of these different interpretations of the standards, and they compete with each other. So it's kind of, they're competitive in the one sense, and yet you want them to be interoperable. Well, getting that interoperability is really hard. It requires a lot of detailed work. These products aren't just standing still, right? You're constantly adding new features to them, improving them, and at the same time, you want to make sure that they interoperate and that you don't break interoperability along the way. So it's a challenging problem. Specifically for the SIP Parity Activity Group, and the reason it came into existence was to tackle these challenges. And at the time it came into being, I think like around end of 2009 was when we started talking about it, maybe 2010 was when we really got going. We had H323-based video conferencing systems, which had been developed by many of the same companies and were fairly interoperable, thanks to good work that was done actually here in the IMTC. Now there was a migration to SIP, and vendors had their SIP-based video conferencing systems, which if you bought everything from one vendor, worked great. But the problem was the interoperability was lacking a bit. We wanted to get that level of interoperability up to at least as good as it was, if not better than with H323, to smooth this migration and really enable it to happen. So within the SIP Parity Group, what we decided to do was provide a forum for members to come together, discuss the major challenges, and come up with some best practices for how we would deal with these things. And where necessary, we would take our requirements back into the standards groups. If we found the standards were lacking something, if they were either something was incorrect or just not exactly what we needed, rather than try to re-implement the standard ourselves, we would take it into the standards group and have them improve the standard so we could continue to be standards-based. And then one of the most important things is to just provide a forum for the different vendors of the different implementations to all get together in a room and let's connect these things up and let's see what works, what doesn't work, and really try to validate the best practices that we're putting in place and improve them where we need to. So I've been talking about best practices. So what are these best practices? Well, we have 3 of them. The first one, the SIP video profile. And that was really focused on audio works great. We don't really have much problem with that. But now we want to add video and H.264 video. And H.264 video, it's a pretty complicated beast. So, how do we add video into an audio call, get it to work in an interoperable way? The role-based video, that was taking it one step further. Okay, so now we have an audio-video call, or an audio-video conference. We want to add presentation or content sharing into that. How do we get that to work in an interoperable way? And then SIP security. How do we secure the signaling? Not only how do we secure the SIP signaling using TLS, but how do we secure and negotiate securing the media using SRTP? So these are the three things we've been working on, and I'm just going to provide you a bit more detail on each of these. And I'm just going to give you a very high-level overview. You will be getting a larger deck that has more slides covering these things in more detail. And please do feel free to look over that and approach me afterwards if you have questions. But in the interest of time, I'm going to just go over some highlights quite quickly. So these are the main things that we tackled with the SIP video profile. How do you deal with asymmetric negotiation? When all you had was audio, you would agree to use the same codec. The bandwidth was pretty much fixed, so that was always symmetric. So it was always a symmetric negotiation. With video, you have different bandwidths that you're able to use. You have big screens, small screens. How do you allow for this to be done in an asymmetric fashion so you don't always just reduce down to the lowest common denominator? Bandwidth indications. How do you say how much bandwidth you want for the entire call versus how much you want for an individual audio stream or an individual video stream? The use of RTCP feedback messages. Those were something that were relatively new, and some systems supported, some didn't. How do you negotiate that in a way that you're able to use them without calls failing if the other side didn't support them? Flow control, there was different ways of changing your bandwidth. You could advertise it in SDP, or you could use one of these new RTCP feedback messages. How and when do you use each of those? IDR requests, when you need to refresh the video. Again, we had multiple ways of doing it that developed over different time. Different vendors did different ones. You could send a SIP info request, but again, if someone supported RTCP feedback, you could use that mechanism. And that was preferred, but you want to use whichever one works. And I mentioned with H.264, there's just, it's a great codec, but it's a complicated codec. There's a lot of different parameters, right? So what we had to do was say, okay, this is the set, a relatively small set, that let's all agree that we're going to use these, understand them, support them in a certain way so that we get at least a certain basic set of H.264 functionality working in an interoperable way. Anything you want to do above and beyond that, fine, but let's make sure we at least get the basics. So I mentioned the RTCP feedback. The problem that we had here was if you just go by the standard, the way you use and advertise that you support RTCP feedback messages is, as opposed to advertising support for the AVP profile, which everyone had supported for years, now you had this AVPF profile. Sorry, a typo there, but it's AVPF. And if you advertise that in a call and the other side didn't support it, the problem you had was the call failed. So we said, oh, well, that doesn't work because then no one advertised it. No one can start using it because you run the risk of call failure. So what do? So we kind of decided to tweak what the standard said a little bit, loosen it a bit, and say, okay, I tell you what, you can still advertise AVP and then just stick these optional extra feedback parameters in the SDP. If the other side understands it, it'll see, oh yeah, even though you advertised AVP, you put these extra parameters in, you must support those. So that way you got the best of both worlds. If both sides supported it, you got the feedback working. If the other side didn't support it, you just went back to using AVP like you always did. And this is just a quick illustration of what this looked like. Now, this is actually going against the standards, but it made a lot of sense for us. So we decided to make a best practice out of it. We advertise AVP, which means you're not using feedback messages, but yet you stick the RTCP feedback messages in the SDP as defined within the standard. So this way you allowed functionality to to be used and to start getting deployed without running the risk of having call failures. So let me move on to the role-based video. We had some new challenges there, because instead of just having one video stream, now all of a sudden you had 2 video streams. How do you know which one's which? We needed a way to control who's presenting at a given time. If you've been in a video conference, I'm sure everyone's been in one, there's someone who's presenting, right? How do you negotiate that? Who has the floor control, as we called it, the ability to present? There's a protocol defined by the IETF just for doing that, BFCP. And we all implemented that. The problem was that BFCP was defined to run over the TCP transport, which if any of you do like network administration, you'll know that in a peer-to-peer mode, getting peer-to-peer TCP connections to work through an enterprise NAT firewall is very challenging. Oftentimes that gets blocked. So we weren't able to use BFCP even though we supported it on both sides. So what did we need to do? Well, we needed to define it to run over UDP so that it would get through these enterprise NATs and firewalls, because now it starts to look a lot more like the audio video streams they were already used to negotiating. So rather than redefine BFCP ourselves, we took that work, we advocated for it within the IETF, and we're just about done now getting that RFC updated so that you can use BFCP not only over TCP as initially defined, but also over UDP. And then the last thing we did in this best practice was, how do you negotiate that? So first you have to negotiate whether or not you support BFCP, but is this the BFCP over TCP? Is it over UDP? How do you get to the best one being used without, again, introducing call failure? So I mentioned you have 2 video streams. This is particularly important where if you had a call like this, you have one system that has 2 screens, the other one has 1 screen. You have to make a choice. If you're this one screen system, which do you show? There's 2. You want to show the right one. You need some context to let you know what each one of those is. And just to give you an idea of what this looks like in the SDP, you can see you have the audio line, and then you have 2 video lines, one in blue, one in green. If you look, you see a content attribute. You'll notice the top one's labeled main, and the green one's labeled slides. That was the convention we agreed to, again, using the existing standards, but we had to establish a convention for how to use those standards, saying your main speaker video, your primary video is main, and the presentation or content that you're sharing, you call that slides. That way, you remove the ambiguity of which one's which. And then you negotiate your BFCP session that I described before, and you need to tie the floor control that you're establishing there to which of these 2 video streams does it apply to? Well, you want it to apply to the content. So you can see there's a label in the green one, label 11, and that same label appears in the red in BFCP under the MStream attribute. So that's the way you tie the floor ID number 1 that you negotiated with the right video line. And then lastly, the SIP security profile. I mentioned you need to be able to not only secure the signaling using TLS, but also the media using SRTP. That actually wasn't too challenging. The challenge came into, as we had with other things, what happens when one side supports securing the media and the other side doesn't? You don't want call failures. So how do you avoid that? And just to give you a summary of what we decided on, we said, well, if the call needs to be secure, there's no problem. You advertise just like the standard says, advertise SAVP, stick your crypto attribute in there. If the other side supports it, your call gets set up, you secure it, everything's great. No problem. If you don't want security, well, you did like you always did. You advertise just AVP, you don't add the S, you leave the crypto attribute out. Again, no problem, it works just fine. The tricky one is case number 3. You don't know if the other side supports it, so what do? You don't want to offer SAVP because if it doesn't support it, your call fails. So you just continue to advertise the non-secure profile, AVP, but you stick this crypto attribute in there. If the other side supports it now, it can answer it back. And this just gives you, hopefully makes it a little bit clearer what I'm talking about, an illustration. This is what you would do if you support it. You support secure media, but you're okay with the call completing non-secure. That's better than it failing. So you offer AVP, put in the crypto line. If the other side supports it, it's going to answer back with the crypto line. If it doesn't, the crypto line's not there. So again, it's unambiguous, and the call succeeds either way. And that gives you an idea of the 3 best practices, and that's actually the end of my presentation. Again, there's more detail in the slides, but yeah, questions. Do I have time for questions? Okay.
I'm in the diagnostics business, so it's secure TLS and SRTP. TLS and SRTP kills us from being able to diagnose why you have failures, being able to read headers, being able to provide SIP ladder diagrams. Can you talk about SIP-REC, where things are? Because being able to get a feed from the SBC or something in the middle that could say, give a diagnostics tool what's going on. Because when these fail and customers are starting to scratch what happened, why, and they don't get calls failure, and everything's encrypted, they don't know what happened. So the great thing about TLS is TLS destroys any diagnostics ability in analyzing media. So is there any work in the standards body, things you could talk about that are going to help us deal with that?
Okay, so when you're trying to do your diagnostics, you're just doing this based on like passive snooping of the network, or?
Yeah, the traditional approach. So the SDN API from Microsoft is great. It gives us signaling on the side that allows us to consume it as an application.
Okay.
Get out of that world, session border controllers. We're on taps and spans, passively watching packets go by.
Right.
Right.
That's always the best way, right? For the thing that knows about what's going on to explicitly tell you, hey, here are the sessions. Now, the other thing you can do, and there's some good work being done in the standards around this, is like, for example, the media. You're encrypting your media using SRTP. Well, you actually don't encrypt the RTP header.
Correct.
You don't encrypt, well, you can negotiate whether to encrypt certain RTP header extensions or not. So the things that are really important for things for diagnostic purposes, or some of the presentations you'll hear later on, or perhaps you already did about main, it needs to be able to understand what is the media stream without decrypting it. That's kind of the way we're moving is, hey, let's move that outside of the encrypted portion and just encrypt the payload that we really do want to keep secure. I'd say that's the best way to go about it. Those 2 mechanisms, explicitly having the application tell you what it's doing, and then not encrypting things that don't need to be.
Yes, SIP-REC is something we think might be promising. I don't know if you're familiar with.
The SIP recording protocol?
Yeah.
Yeah, I'm an author of that.
Yeah. So is that any progress in making that a real standard, or because it's very loose out there in terms of who supports it, what?
Yeah, it's getting very close. The protocol draft's actually in last call and just proto write-up stage. So I'd say it's very, very close, and it's just a matter now. I think a lot of people are waiting for it to be 100% final before they go and really fully implement it. Okay. So yeah, that's coming.
Yeah, thank you. We have to move to the next speaker. Thank you, Charles.